So we should be live on Twitch and on YouTube. Let's see. Yeah. Twitch is here. And no. Excellent connection. Hi. So we have a complete new streaming setup today. Can you hear me on Twitch and on YouTube? Cool. Twitch is working. That's good. Anybody on YouTube yet? Okay, there's not yet anyone watching on YouTube. So cool. Yeah, we're using we switched to StreamYard for streaming, and yeah, complete new setup. So theoretically, we have now less problems with syncing between audio and video. What we had in the past. Let's see what other problems we find today. So let's see if the chat works for, if I can make a post to both really. Test chat message to YouTube and Twitch. Cool. That's working. That in the past we used Restream for that, and I had to copy every message twice. Cool. I hope you all have fun and had fun with watching the .NET Conf keynote. I think it was an hour ago, and now the normal talks are there. So hope there was something interesting, something new for you all. And yeah, now that you're here and not at .NET Conf, yeah, we overlooked it a little bit in our calendars. So. And has anybody already, who has already updated to the final Visual Studio 2022 release and .NET 6? And has somebody of you already a .NET 6 version in production? It's 24 hours after it. No, I'm not crazy. You could have the preview since months out there. So a Hello World app, yeah, but Hello World with .NET 6 looks a lot different than the Hello World apps we were used to it. So is it now one line or two lines? I did not check. I didn't do it myself yet. So they don't need the main method body anymore. Do they have in the template a using system or not? So some pre-stream entertainment. So let's. So now you see us. Let's test it.
Yeah. Hello, everyone.
So we can bet. Is the Hello World console app one line or two lines? So we have one bet on one line. Let's see what's happening. So I should it's so is it now three lines or is it one line or two lines? How do we count this now?
I see three line numbers, 1, 2, 3. Right?
Yeah.
Like, although we don't
I know
Microsoft.
the first is the first is a command. Then we have that. But okay, they put. I didn't have that much time to check the .NET 6 previews, to be honest. And it looks like they added the system namespace into the global usings by default. That's cool. But this template added, the normal class template still has it. Okay. Microsoft. Good. Yeah, we still have, as usual, we start at 15 past 6. That everybody has the ability to join. So in 5 minutes we start with the talk. Yeah, so you have still your chance to get something to eat quickly, get some drinks, that you're then here, and can you put your full concentration on the talk from Will. Good. Nearly 15. So let's try out another feature from StreamYard. Good. Welcome everybody to today's November 2021 meetup. Thank you all for joining and not watching .NET Conf at the moment. Who are we for the ones that don't know us? The meetup is organized by .NET Devs AT. We are a non-profit organization here in Vienna, Austria. Our goal is to spread the knowledge and experience about .NET technologies. We have a website. We are on Twitter. We are on Twitch and YouTube. And we have our own Slack channel. And here are the links to all of them in the chat. Good, YouTube does stupid stuff. And before we start with the talk, we want to thank our sponsors, OGS Software and Services, Theater Avery, Rubik and Rubicon. Without them, this wouldn't be possible because StreamYard is quite a little bit expensive, but cool tool. And also thank you to JetBrains, which provide us with a license, a 12-month license to raffle each meetup, and we are doing this time differently. So we do the raffle now, and to take part in the raffle, you need to write a chat message with hashtag JetBrains in the chat. And I have here a giveaway tool by StreamYard. What should count this? So now it's the first time that we are using this, so please also let me know if it doesn't work. Yeah, we have the first two. So someone will get it. So if and if you won one in the past, you can take part in the last meetup. No, so we have enough keys. So I give you 5 seconds. 5, 4, 3, 2, 1. Good. Let's see who is the lucky winner. Sure. Good. You know how you can contact me, or I send you the license. So in that case, it's easy. Good. Congratulations for the license key. Second thing today is we giving stuff away. So second thing is perhaps you saw us on Twitter. We bought some times ago from Scott Henselman did some Hey Friends t-shirts, and we bought some of them, and I have mine today. And no, this button. And we also raffle one of these now every meetup. And to get one of these, first you have to be in Austria because we have to look at the shipping costs. And the raffle is in the feedback form that I will share then after the talk with you. So, and then you can take part. We have about 4 or 5 t-shirts. So the next month you have the chance to get one of it. And with that, the intro is done, and I welcome Will on the stage, who will us show cool stuff about what it all is doing with the Roslyn API. And
thank you.
Thank you for being here, Will. So you're in Bangkok.
Yes, that's right. Based out of Bangkok, right?
So it's nearly after midnight for him. It's after
midnight
for him.
The time change makes this interesting, right? But I don't have any early meetings tomorrow, so I'm good to go, right?
Yeah. So first, already, thanks for being here, and looking forward to the talk. And now it's your stage, and I share now your screen.
Okay. All right. So you guys can see my screen now. You should see the presentation.
Yes, and questions please in the chat, and I will interrupt Will
thank you.
for the questions.
All right. Okay. Yeah. Thank you, Andreas, and thank you everyone for having me here. I'm really excited to be talking to .NET-Devs.at. So today we're going to be talking about building developer tools with Roslyn. So Roslyn is a really amazing piece of technology. We're all already using it every day, but we can even use it more in our own developer tools and have a really great experience. All right. So my name is Will Fuqua. I'm the head of engineering at Jetabroad. Jetabroad is an online travel agency. We sell flight bookings, tickets on our website. I'm based out of Bangkok, Thailand, like Andreas said. And you can find me online on GitHub. And the reason why I'm sort of here at all is one of my personal projects, CSharpRepl. I've been building this tool for the last maybe 6 months, a year, right? Like that, just hobby project based on Roslyn. And this is a developer tool for C# developers. But CSharpRepl, while it's a really fun project, and I'll be using it a little bit during this talk, it's not the main point of today. The main point of today's presentation is how to build tools like CSharpRepl. So you can build your own developer tools, build your own refactoring tools, your own automations, all based on Roslyn. So before we get started with the full presentation, let me just open up CSharpRepl and just sort of show what it is, so we have a sort of better idea of the things that we'll learn to build in this talk. So this is CSharpRepl, and it's a .NET global tool, cross-platform, works on Windows, Mac OS, and Linux, and it's a command line application, and it's called a REPL, or read, eval, print loop. And this is very similar to if you've seen .NET Interactive or C# Interactive in Visual Studio, or the CSI tool that ships with installations of .NET. It's very similar to that I can type in some C# code here. And you can see I get IntelliSense and stuff like that in the command line. I can then say maybe write line, hello world, like we all do. I can run it and then enter in more code down here. And this is why it's called a read, eval, print loop, right? It read some input, it evaluated it, it printed the results, right? I could say 5 plus 3, for example, and then it loops, right? So you just keep on being able to send more and more content. And of course, it builds on it, right? So I can say hello here, and then refer to it here. So this, like I said, there's other tools like this, like C# Interactive, things like that. What makes this tool a little bit different? First of all, it's syntax highlighted at the command line, which is nice. It does support things like NuGet, so you can install a NuGet package. So if I, let's see, go out of here, say I go to newtonsoft.json, I want to install newtonsoft.json, for example. I can go to NuGet, right? I can get the script in interactive here. I can go back to this tool, put that in there, and then install the NuGet package. And now I can sort of play around with the NuGet package and just learn about it, right? Of course, everything's auto-completed. You still get all the sort of documentation, XML documentation that might be in the package, like this. CLS and JSON, stuff like that. So the goal of this tool is to make it so you don't have to start up a new .NET project when you just want to play around with a NuGet package or play around with some syntax, some stuff like that. It's trying to make it so you can go through and just learn things very easily without having to have a whole bunch of console app 1, console app 2 sort of littering your hard drive like many of us do. It has some nice features. For example, I can press F12 and I can navigate to the source on GitHub for NuGet packages and .NET SDK, stuff like that, assuming the packages support source link. So for example, I just pressed F12 on serialize object. It took me to James NK's newtonsoft.json repository to the serialize object source, which is what I pressed F12 on. So that's .NET, or that's CSharpRepl. Let me switch back to our presentation. But the goal of this is you can download CSharpRepl, you can use it, that's fine, right? Like it's free. But my goal here today is more to talk about the underlying technologies, which is Roslyn. So you can build these own sort of experiences yourself in your own applications. So a little bit about Roslyn. Roslyn is sort of, I guess, maybe the unofficial name, right? The official name is the .NET compiler platform, but most everyone calls it Roslyn. Even .NET, the repository name is Roslyn here. And Roslyn is the compiler for C# and .NET, and a lot of the associated code analysis tools that sort of go into a compiler. It's not new, right? It was released in 2014. I think it was RTM'd as part of Visual Studio 2015. So it's not like a brand new library. It's battle tested. We're using it every day when we compile C#, right? We're using Roslyn. And it's a really, really nice technology. So this presentation, we're going to be going through an overview of the various Roslyn APIs. We won't be able to cover every API because there's a ton of APIs in Roslyn, but I think we'll be able to cover a lot of the more interesting ones, some of the more useful ones. And then how to use these APIs to create your own tooling. And some of these toolings could be, more read eval, print loop, REPL-like experiences. Some of these tools might be more about code analysis and static analysis, or maybe even refactoring tools, code modification tools, things like that. And that's what we're going to be talking about today. All right, so let's talk about sort of before Roslyn, right? Before Roslyn, our compiler was a little bit of a black box. We would feed in text files. We'd feed in maybe C# or VB into our compiler, right? Out the other end of our compiler would pop some assembly, right? A DLL, a EXE, like that. But we didn't really see what was going too much inside the compiler. So if you wanted to do analysis of your own C# code or evaluation of your own C# code, it's a little bit tricky, right? You might end up re-implementing parts of the compiler or something like that, re-implement your own sort of C# parser. So what Roslyn does is Roslyn makes that not a black box anymore. With Roslyn, we get a ton of rich information about the compilation process. And that happens because Roslyn is both a C# compiler that you can run at the command line, like normal, it powers the normal C# compiler, but it's also a library. You can add this as a NuGet reference to your own application and then get access to all these classes and types that the compiler uses to compile your code. And so then your own application can use these APIs, right? If you want to do some code formatting, you want to do some syntax highlighting, right? You want to go work with IL. You can use a lot of the tools that are built into Roslyn to do this without having to sort of reverse engineer or run the compiler at the command line, right? You can do all this as a library with Roslyn. So like I mentioned, there are a ton of available APIs with Roslyn. The way that it works, it seems, is that there's these internal classes, right, that are internal to Roslyn that we're using, that are being used to compile the code. And then when a need arises or it becomes more stable, the Roslyn team will then make that public, right? They'll switch that class, some internal class, to some public class. So you end up with a whole bunch of available classes to use with Roslyn. I've tried to sort of group them for the purposes of like understanding. I've tried to sort of group them into 4 main areas. This is not like a hard and fast rule, right? This is more just sort of more of a general grouping. There's a lot of sort of classes that go along inside all these groups. But we have the compiler API for analyzing, modifying, and compiling code. We have the Workspace API for analyzing and modifying solutions and projects, things like that. We have the Diagnostic API, where we can create our own sort of compiler warnings and even suggested fixes, automatic fixes. And then finally, we have the Scripting API, right, where you can run C# code as a script. So for this presentation, we're going to go through each of these APIs, go a little bit more in depth, see what they are, how they're useful, how we can use them in our day-to-day programming and operations, maybe stuff we do at work or in our own side projects. And we'll be going through each of these. So let's start out with the compiler API. The compiler API, I think we actually already saw this at .NET-devs.at. I think, was it 2 months ago, we had a source generator presentation that used the compiler API. I've linked this down below. If you didn't see that, that's a link to the YouTube on .NET-devs.at. And that sort of used the compiler API to do code generation at compile time. We won't really be talking about source generators in this talk because we already had a full presentation on source generators, which was excellent. But we will be talking about some of like what are the compiler APIs and how we can use them maybe in other ways outside of source generators. Okay, so just to start out, if maybe you didn't see the previous presentation on source generators, let's just talk a little bit about what is the compiler API. So say we just have a very simple statement, 5 plus 3, maybe an expression, I should say. We have a 5 plus 3, right? Like, and we're maybe going to be compiling that. How does the compiler model this code? It could model it as a string, right? Just as a string 5 plus 3, but that's ultimately not very useful. The compiler needs to be able to go evaluate this, traverse it, and understand it so it can generate the right code. So it's going to use what's called a syntax tree. So in this, on the left, we have some code, 5 plus 3. On the right here, we have maybe a way that a compiler could model this, right? It has a plus sign, and then it has a left and a right, where the left is 5 and the right is 3. And this is a sort of like a data model that a compiler could use for modeling the code on the left. And so when it needs to go evaluate code, it can go sort of traverse this data object and then write some IL code that will be emitted when we compile this code. So that's a very simple example. Next, let's look at some real C# code, right? Console.WriteLine hello world. For this console.WriteLine hello world, the syntax tree that's used is quite a bit bigger. This is what Roslyn would use to model this. And while it might look quite large at first, it's similar. It's very conceptually similar to what we saw before, that simple 5 plus 3. It's still ultimately a tree data structure, right? So you can see whether there's an expression statement, there's an invocation expression because we're invoking something. We have some member access going on, an argument list. So you can see it's console.WriteLine, right? We're accessing the member WriteLine in console. So we have console.WriteLine. We provide to it an argument list, where our argument list is just a simple argument. It's a simple string literal expression of hello world. And then finally, we have a semicolon at the end. We also have some nodes in this tree that are tracking white space, right? In this example, we might have some leading indent potentially on our console object. So we have a white space here. We also have an end of line marker here. So while this tree is a lot bigger and it is more complex than our previous example, it's still ultimately a tree. We're still modeling our code with trees, parsing this text into a tree so the compiler can understand it. And now we can use the same data model in our code. Before we go too much farther, I just want to show sharplab.io, right? I think we actually saw this in the source generator presentation as well, but it's still worth, I think, reiterating because it's such a useful tool. So say I have a using system at a console.WriteLine hello world, like that. If I say I want the syntax tree, there's a whole bunch of different options that I can decompile it. But if I go to the syntax tree, I can see how Roslyn is modeling this code. So here, I can see I have a statement, which is console.WriteLine. As I mouse over this, you can see it highlights the line that it represents. And I can go through here And I can see what we saw on our slide before, that we have our expression, which is a member access, right? We're accessing the right line member of the console class. And then we have this argument list here. If I were to drill down to this argument list, I see the token hello world. If I did another thing here, like I said, var x equals 5 plus 3, then I can see we still have, if I collapse this, we still have our using global statement. So we're still in a massive tree here. If I sort of zoom in on this global statement here, I can see we have a variable declaration. And ultimately, we have an add expression, the plus sign, and we have the left is the 5, and the right is the 3. Right? So this is all just to say that Roslyn is doing this understanding of our code, it's presenting it in a structured manner. And we can take advantage of this to do our own code analysis or even code modification. So we don't have to go do string parsing or regexes or anything like that to modify code, where that works sometimes, right? But it's really not a good way to do it, to represent a whole bunch of different types of code, to do it in the general case. In the general case, we want to work on something more structured, not just strings of code. All right. So we can use Roslyn's understanding of our code. And then, of course, we like LINQ. LINQ is great for sort of querying and understanding sort of these structured data. And so we're going to be using Roslyn's data model and our LINQ to query our program structure and maybe do a little bit of simple static analysis. All right, we're going to be doing some very simple static analysis here. We have our console.writeLine hello world, and we want to see what is the message, what is the string literal here that we're going to be printing. This will just be a very simple example of static analysis. It's trivial, just to sort of show the APIs that are being used. And then after this, we'll go into see what are some real world uses of this. So for this, I'm going to switch over to CSharpRepl just so we can play with the code a little bit. Let me clear my screen. Okay. So I'm going to install the Microsoft.codeanalysis.C# NuGet package. Okay. So I do that. And then I'm going to import some of the required usings here, right? So we have to sort of import the core code analysis, which is sort of the core shared Roslyn types, and then some C# specific, because Roslyn is both for C# and Visual Basic, and then another additional syntax library here. So let me position this here so you can see. Okay, so I'm going to go ahead and make a tree. Okay, and I'm going to parse the text here. So actually, I have an existing little project here. If I look at this program.cs here, I have a .NET 5 hello world here, and I can say .NET run, right? And we have this hello world. Shouldn't be too surprising. So let me just go ahead and pull that in here. Let's see, this would be in hello world program.cs. So I'm going to read in my program, and then I'm going to parse it, semicolon, of course. Okay, so now I have this tree data structure. So now at this point, Roslyn has parsed the input, and we have this tree, which is structured data. Right now, it's showing like a toString, right? Like, but I can go inside and look a little bit deeper, and I can see we have a whole bunch of very rich information about this data type. So I'm going to get the root of my tree. I can get all the descendant nodes. That's an enumerable of all nodes in the tree. I can maybe just list it here. And now if I run it, I can see we have all these nodes here that are part of our program. We can see we have a using directive for the using system, right? We have our console.writeLine. And then ultimately, this is a traversal of the tree. What we care about is this hello world, right? We're trying to figure out what message we are printing. So now I can just use LINQ. In this case, there's a bunch of different ways I could do it. Maybe one way would be of type, literal expression, syntax dot single. So that gets that node. And then I can go get the text of that node, hello world. So what we've done there is we loaded our C# program into our own little program, right, using the Roslyn APIs, and I was able to use link to go and grab this hello world here, which is this hello world here. So if I go through, that's just the rest of the code in the presentation, just so we can share it later. So that's just a very simple way of querying our program structure. We don't just need to program, we don't just need to query our structure, we can also modify our program programmatically. So let's say we have our simple program here again that says hello world, and we want to modify our program that says to say hello Roslyn. Now, really, if it's just a one-liner here, right, that's probably not worth doing programmatically, right? But we can see that this will generalize into a wider program analysis. You could go replace a whole bunch of different console.write lines or do some automated refactorings across your code, all using link. So for this, I'm actually going to switch over to Visual Studio. Okay, we have our hello world here. This is the program we're going to modify. We have our program.cs here. These codes so far are identical to what we've already seen, right? We're reading in our input file, we're parsing the text, we're getting the root node of our tree, and then we're traversing it to find a literal expression, right? That's our hello world. Now, what's new here, so that's basically the query, right? So we're saying, here's our message that we're saying. Here's our message that we're going to be printing. So now the new part here is next we're going to modify our program. So the first thing we need to do, we have our old message here. Maybe I'll just rename that to old message. We have our old message here that's in our existing program. We can create a new message here. So we're going to be replacing hello world with hello Roslyn. So we make a literal expression of type string, and that's hello Roslyn here. So now we have our old message here. And if I show the explicit type here, we can see that's a literal expression syntax. We can see that this is the same type here. Oh, maybe can. Okay. My IntelliSense is not coming up, but here, I'll just type that literal expression syntax there. And now we have this root reference to our syntax tree, and we can use this very handy replace node function that replaces the old node with the new node. Now, one thing to note about this is immutable, right? Roslyn is immutable. The syntax tree is immutable. So when I say replace node, it's not mutating the root of our tree. It's actually returning a new program, right? It's returning a new root node that represents all of our program. This is a very common mistake that people do when they're getting used to Roslyn, is that they forget that everything's immutable. So they're doing all their replacements and stuff like that, but nothing's actually working, right? Because they're not retaining a reference to the new one, right? A lot of people will just do something like that. That's not going to work. It's going to return a new program, and you're just never going to use that new program. Okay, so now if I run this program, let's go take a look at this. Okay, so we have our hello world input, which is our target file that we're going to be modifying. I'll delete that output. Now I'm going to run this. Oh, I have to set my startup object, of course. Okay, and there it is. That program is done. So if we go take a look at the output, it's now from this input, it's gone and modified the program to say hello Roslyn instead of hello world. Okay, so that's a very basic example of both querying our program structure, where you could maybe query your program to go find, bad code or maybe dangerous scenarios or warnings, things like that. It's also an example of modifying our code, which is just a very first steps in potentially doing some refactoring, automated refactorings. All right, so next I want to talk about just a couple of ways that I've actually used the compiler API at work. And it was just a way to sort of improve code quality without spending way too much time. So now this is an example of some bad code. This code is a little bit dangerous. So it's, like I said, that we are, at my job, I'm working at an online travel agency, so we care a lot about flights. So here, maybe this is one way that you can model, maybe a one-way and return flight. You can see it's kind of like a fake enumeration, right? I have this flight type, I have some static read-only instances, so I can say flight type dot one way, flight type dot return, maybe some other flight types as well. And then in other areas of the code, I can say, oh, if the selected flight type is a one-way flight type, do a one-way flight search. So this is like enumeration, but then it also has, some data built into it, right? Maybe a string, some configuration data, stuff like this. So this compiles just fine, but it's dangerous, right? It's dangerous because I'm not implementing I-equatable here, right? Like I'm not doing anything about structurally equatable. I'm not using records. It's just a normal class, right? Like I-equatable is not implemented. So that means this is going to be instance equality, right? It's actually going to check to say it's this, check to see if it's the same instance in memory. So why this is dangerous is it mostly works, right? Like, and those are sort of the most dangerous things, that it works on development, right? Maybe even works in production mostly. And so this, if we have this static read-only instance, in most cases, if the flight type is always set from this instance, it'll work. This, and so it'll work on one machine, it should work, assuming that all the flight types are set to the same instance. But as soon as you start doing something a little bit more complicated, like you start doing serialization, maybe you start having multiple machines in production with, maybe shared Redis state, for example, or shared database state, session state, something like that, then all of a sudden this instance equality doesn't hold. We had a similar scenario to this actually bite us in production, and the root cause was that we were moving from one big machine to multiple smaller auto-scaling machines, and we found this sort of similar issue. That this had been working, right? Like, but it just sort of silently failed in production because the instance equality was being used when people didn't expect it to be used. Because it looks like an enumeration, people kind of expected it to be a value type, a value object, but really it's something more complex than that. I think today, if you were to write this code in Visual Studio, I believe Visual Studio would probably warn you. I'm not sure about that, but I suspect it would. I think there's a lot of good analysis built into Visual Studio. This was about 5 or 6 years ago. We didn't really have that. So what we wanted to do in this case, we found this one case, but we didn't know how many other cases were there in this code base that's hundreds of thousands, if not millions of lines of code that could potentially be waiting to bite us, right? So it's a fairly simple link statement to figure this out. I think this ended up maybe being 40 lines of well-formatted, commented code to go find all places in our code base. We were doing something that looked like value equality, but it was a custom type that didn't have I-equatable. So that's a real-world usage of our compiler API. Another one we did, this is actually about modification. That previous example was just about sort of detection, right? Saying, hey, go look at this type. This looks dangerous. You should go refactor this potentially. This one is more about actually modifying the code. So we had a lot of unit tests around this, around our system. And as you can imagine, in an online travel agency, we're constructing a lot of flight objects in our unit tests. So in our unit test, there's a whole bunch of test data like this on the left, where we instantiate some flight. A flight has an airline, a flight number, a price, something like that. It has a whole bunch more attributes other than that as well. And whenever you wanted to go change something in your flight domain model, you had to go through and potentially modify a whole bunch of unit tests, or you might have other unit tests start failing because they were constructing data in ways that you didn't expect, right? We had thousands of unit tests here. And what we wanted to do is we wanted to put it behind a facade, right? Put it behind some sort of builder. So then we could just have some centrally defined test flight builder object, right? That would construct our unit test data. So you could pass in parameters, but then it would make sure certain invariants hold and give you one place to sort of change how you set up test data in your unit tests. This is another example, is very simple to go through. And wherever we found a constructor to the new flight, we would go and highlight that and insert a test flight.build and then put these as named parameters, put all this data as named parameters. Finally, and probably one of the most interesting cases and most real-world cases that we did that we can actually share is we wanted to migrate from NUnit to XUnit. So NUnit is on the left here, XUnit is on the right. We want to migrate our tests from NUnit to XUnit. You can see on the left is NUnit, and we attribute our class with test fixture. We have a setup method that we attribute with setup. If you had a teardown, you would attribute that with teardown. And then there's other various changes as well around test data and inline data and stuff like that. We wanted to go to XUnit. So the example for this converted to XUnit would be this, that you don't have a setup method, right? You just use a constructor. You don't have any sort of test fixture object. Also not shown in this example, you would implement iDisposable instead of having a teardown method, stuff like that. So for this, there's this built-in type into Roslyn called C# syntax rewriter. And while you can definitely use replace node, like we saw in our hello world example before, for larger changes, you might consider using the C# syntax rewriter. This is a visitor pattern, right? If you're familiar with a visitor pattern, where you can maybe subclass this visitor and then visit all the nodes in a tree. This is the visitor pattern. You can see there's a whole bunch of methods here that Microsoft provides for you. And you can override one of these or many of these to sort of do your program modification if you want to rewrite syntax nodes. So for example, maybe you have a constructor declaration, right? You want to go visit all your constructor declarations. Or you want to go visit all the discard patterns in your code, right? You can subclass this C# syntax rewriter, override what you need to override, and you pass your code to the C# syntax rewriter, and it will call your code, and you can transform all the various different parts. So I'm going to go here. This is our NUnit to XUnit converter. You can see it uses the visitor pattern. So for example, in that example code, we wanted to replace the setup method with a constructor. So we have our subclass here, a C# syntax rewriter. This is actually a partial class. We kind of split up into multiple files, one for each override that we're doing. And if we go take a look at this, for example, setup method to constructor, which is changing the setup method into a constructor, you can see it's not a lot of code. Let me zoom in here a little bit. Right, this is all the code required to do this transformation here from this setup method here to this constructor here. So basically, we have a class declaration which represents our entire class. We go and find a method that has an attribute with a setup. This is an extension method, but it's very simple. It goes through, just like we saw in our hello world, we're going and getting the descendant nodes and doing some link just to sort of filter down what we want to do, what we want to get. And then we create a new constructor, a brand new constructor with the same body as our setup method here that we found here. And that's enough to replace all the test method setups with our constructor for XUnit. We did some other things as well. Like I had mentioned before, if I go to the class visitor here, we also change all the teardown methods in NUnit to iDisposable implementations and actually add the iDisposable implementation, stuff like that. We also do some stuff for member data, right? If you want to provide sort of data-driven tests. It's ultimately, it's very straightforward code. It's remarkable how little code it really is with Roslyn. Okay, with a lot of these refactorings, I think the Pareto principle is your friend. The Pareto principle states basically, it's like an 80-20% rule, right? 20% of the code takes 80% of the time, right? Or 20% of something that you do, generally that last 20% takes 80% of the overall time. And this, I think, is useful when you're doing some of these refactorings like NUnit to XUnit, right? For that NUnit to XUnit project, it's not perfect, right? But it does handle most of the scenarios. It handles 80, 90% of the scenarios. We didn't bother automating that last maybe 10%. That last 10% we just did manually. But really, automating only 80% or only 90% of the work across a large code base is a huge win. And just by doing a little bit of link, right, you can automate a huge amount. And then maybe there's some edge cases here and there, some weird code patterns here and there that don't quite work. If you're just doing sort of ad hoc refactorings like this, that's okay. If you have a product where actually maybe you want to build real refactorings, then you do have to go do 100% and handle a lot of the edge cases. But just for your day-to-day job, maybe you just want to do some simple refactor. Just with a little bit of link, you can really save yourself a lot of time. All right, so that's it for the compilation API. Next, we're going to go take a look at the Workspace API. So the Workspace API is really focused on solutions and projects and documents within those projects. The compilation API was really just focused on C# code. It didn't really have any concept of, multiple files. It didn't have any concept like that built into Roslyn. The Workspace API provides that concept. So here we're building a workspace, which is something we can use to open a solution. So for example, we're opening an SLN file, my solution. And then by opening that, then we can sort of traverse all the projects and documents and then the C# code within those documents as well, all as part of the Workspace API. So this Workspace API works really well with the compilation API that we just saw previously, right? This Workspace API gets you to the projects and the documents. And then for the code within those documents, then you can potentially use the compilation API to go do your analysis or modifications, things like that. Here we're saying MS Build Workspace, which you'll see that most of the time we use MS Build Workspace because most of the times our solutions are MS Build based. So this MS Build Workspace is what you'll use the vast majority of the time when you're working on real code on your file system. You might also see something called an ad hoc workspace, which is not MS Build based. It's just more in memory, right? You maybe just want to build up some in-memory projects or documents, something like that. You could use ad hoc workspace. You'll see that sometimes. For real-world solutions and projects, you'll almost always be using MS Build Workspace. So here we're just writing a little bit of link just to traverse that solution and project and document hierarchy of data. And so again, using link. And then this Workspace API also does allow modifying as well, not just traversal. So here's how we can use the Workspace API along with the compilation API to implement find all references via C# code. So just like in Visual Studio, you can right click on a method or a type or something and say find all references. We can do that in C# code as well and print out all the references. We don't have to use Visual Studio for that functionality. And Visual Studio is using these same Roslyn APIs under the hood to implement their find all references. So it's all just the same libraries that we can use from our code. So here I'm getting reference to a document, which just as you might expect, represents a document full of C#, right? It's a C# file, essentially. So we're just going and maybe getting, the first project in our solution, the first document in our project, just to get a document reference here. Then we can use the compilation API, right? Just like we saw in our Hello World example, right? We can get the syntax root of our tree, go get the descendant nodes, and maybe we'll just find the first method declaration to keep it simple. Then we need to do something called get the semantic model of the document. So this semantic model, you'll see this used a fair amount in Roslyn code. Previously, we were looking at the syntax tree, which was much more sort of syntactical information. Syntactical, if that's a word, but you can basically get the syntax level information, say this is a class, right? You can say that is a constructor, but then your very next question is maybe that constructor, what is the .NET type of that constructor, right? You want to get some sort of .NET type or something like that. That's when you use the semantic model to get the more rich information to sort of do these find all references and get type level information of your code. So here, we're going and using the semantic API on our document, right, to get this semantic model. And then we can use this symbol finder class that's built into Roslyn, right? Symbol finder.find references async. It takes the symbol, which is our method that we found up here, right? We found our method, and then we got the rich information of that method from our semantic model. Then we say find all references of that method in the solution, right? Whereas that solution is our solution up here that we loaded previously. So again, it takes some code, but it's not too much, right? Really, to say this, to do find all references async, or to find all references in your code, it's not too much code. We have this very handy find references async. You just need to do some preparation to go find what do you actually want to find references to. All right. And then here's a real world use case of the Workspace API. When we started out at Jetabroad, we had this code base that was developed by a consultant. And this was years ago, like decades ago, right? And the unit tests were actually in the same file as the type being tested. So this is an example where we maybe had some serializer class or something that needed to be tested. The unit test would actually be defined here in a pragma here for a conditional compilation. So if you define some unit test symbol here, then it would run and you'd have this. And that means that your your unit tests were actually inside your main projects that were then deployed to production. So this is a fairly unique setup, and we didn't really like it. We much rather have a more typical setup where maybe you have your C# projects that are your actual sort of production that's actually running in production. And then you have some companion projects potentially in a tests folder that have your unit tests. We were able to use the Workspace API to very quickly navigate through our projects and solutions, and then find all the documents, and then locate all these if unit test pragmas, and then pull those out to another file that were mirrored in a test project. This is probably fairly unique to Jetabroad, that you don't really see this you don't see this setup too often, and we didn't really like the setup at all. But it shows, I'm sure you can think of problems you might be having maybe at your work or maybe in your personal projects where you might want to do some refactorings like this across many different files. And that's where you can use the Workspace API. The Workspace API really often works in conjunction with the compiler API. And again, I think maybe this was 20 or 30 lines of code to do this, right? Across thousands of test files. Okay. Finally, I want to talk about syntax highlighting, which is available in Roslyn using the Workspace API. For this one, we'll actually go do a little demo. So we're going to be using the classifier API here. So if I go take a look at the MSDN documentation here, we have this in the Microsoft.code analysis namespace, we have the classifier.getClassified spans. All right, so let's go over here, do this. Okay, so here's how you can do syntax highlighting. This is going to be doing syntax highlighting at the command line using the code analysis APIs. So I'll just show the CSBrod real quick. I've pulled in a NuGet reference to Microsoft.codeanalysis.csharp.workspaces, right? So before we were just dealing with this for the syntax level analysis and modification. Now we're going to be doing stuff with the Workspace API. So I'm going to pull in the Workspaces NuGet package. So here I just build up a very simple in-memory solution and project and document, right? So we just have a single solution. We add just a very simple project. We add a domain, or we add a document to that project. And inside that document, we have this little class. So I showed that classifier type on MSDN. We're just going to call that. We're going to say, get me all the text of the document. and now classify it. So I'm going to put a breakpoint here, and we'll run this. Okay. So now I called the classifier API to get the classified spans. So I have this classified spans here. So span in this sense does not mean the newish type span of T. Span here just means a span of text, right? For like from index 0 to index 5, for example. So what this is saying is, you can see it here. Actually, maybe I can zoom in here because I think I can't make that a little. Can I zoom in here? Yeah, there we go. Okay. Let me zoom in so you can see in the debugger. Here you can say that the classifier API said, oh, we detected that from indexes 0 to 5 is a keyword. So if we go to index 0 to 5 here, right, that's going to be starting 0, 1, 2, 3, 4, 5, right? So that's the class. It's saying that class is a keyword. I go maybe look at the next one, it's going to say from 6 to 13 is a class name, right? So that's going to be the program in our example. So this is not doing anything about coloring yet. It's just identifying what are all sort of like the types, or the almost parts of speech, you could say. What are the types of the keywords and classes being used here, right? Saying from 34 to 38 is a method name, right? That's going to be our main method. So it's doing all this classification for us. Let me zoom out here. So now from here, in this little example, all we're doing is taking this information and then setting the foreground color of the console, saying that if it's a keyword, we want it to be magenta, class name, we want it to be cyan, string literal, we want it to be yellow, and then we just write out all the text in those colors. We have a sort of a minor detail here we don't really need to care about, basically saying if something's not classified, just make it colored white, make it a default color, because not everything will be classified. And then we're just going to print this out. So if I continue here, you can see that we printed out this program, this text here, syntax highlighted, using the classifier APIs. I can zoom in here a little bit as well. Right, so this is saying here for the keyword, right, make the keyword magenta, make the class name cyan, right, here, and then make the string yellow here. So that's a real quick way to syntax highlight code. Here we're rendering to a terminal, but you could render anywhere. You could render to a web UI, right? You could render to something in WPF or UWP or MAUI, anything like that, right? The classifier API is just telling you what are the classifications, and then it's up to you to actually sort of do the highlighting and the coloring.
Will, we got a question.
Yes.
Roslyn can do the same with Razor code?
Can Roslyn? Oh, that's I don't actually know that. Can it
and
highlight? You know, that's a really good question. I don't actually know. I don't believe it can. I've never seen anything like that in any of the APIs I've been dealing with. I don't believe it can do syntax highlighting. Or I'll take a look into that, see if I can get an answer for that maybe after the show, right? Like the classifier get classified spans, I believe it only works on the Workspace API, which has C# and VB implementations, C# and Visual Basic implementations. So I would be very surprised if it worked in Razor. But it's possible. It could be a new feature I don't know about.
Thank you.
Okay. All right. Okay. So that's the Workspace API. Oh, actually, sorry. One more thing I should show if I go back to the demo, right, we have these keywords, these class names, these string literals. I can F12 to this, right? And this is in the codeanalysis.workspace API. I can see all the various things it can highlight, right? So I can scroll down here. I can see it even supports, record struct, which is a fairly new feature. Extension methods. It can do XML doc comments. It can do some degree of XML literals, but that's mostly just focused on doc comments. It can actually highlight within regex, right? In Visual Studio, newer version of Visual Studio will actually highlight within your regex and give you syntax highlighting within your regex. So you can use that as well. So based on this, I would be very surprised if it did Razor, because I don't see anything Razor in here. But you can go and see all the various things that it can return here in this classification type names object here. Okay. Let me close the zoom, this magnifier UI. Okay. So next up, the third out of 4 APIs that we'll talk about is the diagnostic API. This one is really pretty useful, that we will be able to give sort of custom warnings and custom fixes to C# code. So most people are probably familiar with maybe like the light bulb icon, right? Like that can show up in your code, where it can automatically detect certain scenarios and then in some cases fix those for you. So for this example, it's seeing a string.format and it's saying, hey, would you like to replace this string.format with an interpolated string like this? This is showing the diagnostic API in Roslyn, and this is available. You can write your own providers for this very easily. All right. So the diagnostic tools here, you have a diagnostic analyzer and a code fix provider. The diagnostic analyzer is what detects certain scenarios that you want to warn about, right? You can just give a warning and say, hey, watch out for this. Or you can couple it with a code fix provider to actually fix that. And these diagnostic analyzers and code fix providers, they're using all the same Roslyn APIs we've already talked about, right? Where you can use link to parse, or you can use link to find certain scenarios, and then use APIs to then modify the code. All these replace node and rewriters that we've been looking at so far, you use those core tools to plug into this diagnostic analyzer and code fix provider, and you can implement your own. Historically, it's been packaged as a Visual Studio extension. You might know about, for example, Roslinator or SonarLint, which is part of the SonarCube project. You've sort of done them as Visual Studio extensions. Although somewhat recently, in the last year or two, you've started to see a lot of NuGet packages implement this. And you can see this if you go to Visual Studio. For example, I'll go to this, maybe I'll go to the CSharpRepl source code. In modern project types, you can have this analyzer, and I can see that Roslyn itself is providing various different code fixes here. So I installed this NuGet package, right? Microsoft.CodeAnalysis. It installed a whole bunch of analyzers for me, and these are all powered by Roslyn. I could also potentially go over here. Do I have any over? These projects are so simple. I have some analyzers. I have a system.tech.json source generator, and then I also have some analyzers here as well. And so these are all powered by Roslyn, and you can make your own. You can package them via a Visual Studio extension that you install, or you can package them as a NuGet package. You can bundle that along with your NuGet package to have these warnings. So here, I'm actually not going to really go into this one too deep in this presentation, mainly because Microsoft has really good documentation here. Microsoft has an amazing tutorial for writing your first analyzer and code fix. It walks you through how to install everything, how to set up everything, right? The example here that's doing is find local declarations that could be constant. And it walks you, just like what we've been seeing, walking through the syntax tree to go find find all these scenarios. And then even writing a code fix here. Right, using link, just like we've seen before, right, to go through and actually update the code. So the documentation here is so great. I'm just going to link to this documentation and not try to explain it more here. If you're interested in doing this, go check out this tutorial that's linked here. It's really good. It'll set you all up, and you'll be able to write your own analyzers and code fixes. Okay. Finally, I'm going to talk a little bit about the scripting API. The scripting API is one of the core APIs that I was using here in CSharpRepl, as you might expect, to actually go and evaluate code without having to go invoke a compiler, right? Just using the scripting API. So for this demo, for the scripting API, we're going to build our own REPL in just a couple lines of code. So let me go here. So this is what we're going to build. I'll go ahead and start it so we can see. Okay. And I can say, maybe using system. Here, I'll zoom in a little bit here. All right, I can say var x equals hello. Okay. And then I'm going to say console.writeLine X. It prints out hello. So that's already a pretty impressive little REPL, right? Like it's able to evaluate code, is able to chain code. This using system then builds on top, right? Like then we can define a variable and then print out that variable. It might be surprising how little code there is in this demo. This is the entirety of the program. That little read eval print loop, right? Like is just contained in this 17 lines of code, right? So we loop until the user types exit, right? We're going to print out a little prompt. We read the input, we evaluate the input, we print the return value, and we loop, right? So it's a very clear little read eval print loop. So if we go into this a little bit more, so we have our scripting namespaces here. If I go into this CSproj, right, we have our Microsoft.codeanalysis.C#. Now we're calling .scripting, right, to pull in the scripting APIs. And so the core evaluation is happening here. Everything else is really very simple about reading console input, writing console input. So what we do is we have this script state. This script state is tracking, well, the state of the script, as you might expect, across all of our lines that we're evaluating. So initially, script state is null, right, because we're setting it to null. So we run the input, right? This input is a string, right? So we run our string input, and we get back a script state. And then subsequent loops, iterations of the loop, will then build on the script state and then call continue with, right? This continue with async, it's not the task.continue with, right? Like this is its own continue with that's a member of the script state type. And that will run this string input in the context with the state of this script state. And then finally, we have a return value here. So that's a very easy way if you want to add a little bit of scripting to your developer tools, right? And there's a lot of different various APIs we could also be using here to make it more and more rich. But this scripting API is very easy to use, and you can get a very simple REPL up and running very quickly. All right. Let's see. So for our REPL, right, there's a whole bunch of stuff we could now improve. Maybe a next good step, if you wanted to take that demo code and turn it into something a little bit more real, right? you might want to add a nice set of default usings and assembly references, right? Right now, we don't have any. I had to say using system in order to get console.writeLine. You might also want to import, I don't know, system.link or something like that, potentially by default. That's up to you. Another key part of the scripting API is the metadata reference resolver. This is sort of a built-in extension point into the scripting APIs. And this is what you would use to implement referencing assemblies via this #R syntax, which is relatively standard. And you can implement all sorts of things. You can implement NuGet libraries like I did in CSharpRepl, projects, solutions, just allowing you to reference any sort of thing. So this metadata reference resolver is a nice extension point you could use for the scripting APIs. You might also want to allow importing of other files within your REPL. For example, you might want to say load, and then you say, for example, like that, right? To import some C# code into your REPL, into your script. And then sort of the core thing that CSharpRepl is doing, that project I have, is you can also work out some synchronization to synchronize your code that you're evaluating in the REPL with code in the Workspace APIs if you want to implement syntax highlighting and IntelliSense documentation, for example. You could also use the semantic API that we showed a little bit earlier to make our REPL understand our code a little bit more. So I've done all of this in CSharpRepl, right? You can refer, like we saw, you can refer to NuGet packages, for example. Here, you could say using soft.json here. I think I showed this potentially before. That's done via the metadata reference resolvers. Load support is also there if you wanted to include other files. Of course, syntax highlighting, like we saw in that little demo for doing a very quick console-based syntax highlighter, that's also here. Going and doing IntelliSense, getting all this documentation from the XML docs. And then if we wanted to use the semantic API, for example, I could say datetime.now. I can press F12 here to go and pull up more rich information about datetime.now, for example. All right. Okay. So that's about it for our presentation. We've gone through Roslyn, gone through a lot of APIs here, but hopefully that gives you a bit of a top-level view of what are the various different parts of the API, and maybe gives you some ideas for things you could potentially automate in your projects, automate at work if you want to do some refactorings or static analysis, stuff like that. I have provided a bunch of links here where you might want to go check out some of these projects. This first one is my project with CSharpRepl. There's also .NET Interactive, which is again built on top of Roslyn and with a little bit more of like a Jupyter Notebook focus, right? If you looked at .NET Interactive, it runs in VS Code and gives you some scripting possibilities in Visual Studio Code. There's also .NET REPL you might want to go check out as well, which is powered by .NET Interactive. There's .NET Script, which is a really interesting project. It's more about running C# code from the command line as a script, sort of similar to Script CS, if you're familiar with that. And then finally, there's OmniSharp Roslyn, where OmniSharp Roslyn is what I believe is powering VS Code. Their C# syntax support is done via OmniSharp. Vim, if you want to write C# in Vim, also you can use OmniSharp Roslyn to go get nice syntax highlighting and rich IntelliSense and stuff like that in Vim. So that's everything. So thank you, everyone. That's my presentation. Now I'd like to open it up for any questions.
Thank you, Will. I didn't notice any questions yet in chat, but
okay. I'll make these slides and code available, I guess, via a link Andreas, I'll talk with you and we can share this link if people want to go play around with some of these APIs and some of this example code, as well as slides if people want any links.
Yeah. Yeah, give it to me and I can then share it with the people.
All right.
Good, but yeah, some thank yous.
Okay.
In the chat.
Thank you, everyone. Thank you.
Not, but no.
All right. Well, it's been really nice, really nice meeting you guys here at .NET Dev.at. Right. It's great. At some point, maybe we'll need to have a little bit of a cross collaboration, right? .NET Dev.at, and we also have, of course, .NET Bangkok as well, right? Like get these virtual meetups going more and more.
Sure. Let's make the best out of the situation we have, and yeah, getting different speakers from different parts of the world to your meetup. So
yeah, it's really a great opportunity. We've been doing it at .NET Bangkok as well, right? Getting people from all over, right? Now that everything's virtual, it's really cool.
Oh yes. Good. Then, Will, thank you.
Thank you
for the time. What every speaker is getting from us is one of our custom coasters with our logo.
Oh, that's great.
So, yeah, if you send me, we are in touch. Send me your address, and then I will.
Yeah. I'll definitely do that.
You.
Yeah, and thank you so much.
Thank you for spending your sleeping hours with us.
Yeah.
Good. Yeah. Also, thank you to all of you for joining. Also, thanks to our sponsors, OGS, Every, and Rubicon, and also JetBrains for the license. If somebody, if your company or you want to sponsor us, please get in touch with us. Look up for the future next meetups. So we have some cool meetups already in the pipeline finally. So for December, George Ramirez will talk about building connected things with Matter and C#. Matter is this small IoT board what you can program with .NET, and it speaks .NET Standard 2, when I remember correctly. So this is in December, and in January, Meinrad Reicheis will talk about one of his open source libraries, MudBlazer. It's as far as I remember, and it's a component library for Blazor with different controls. Yeah, looking forward to these two. And yeah, please spread the word that we are doing these meetups. Try to do it every month. So in the last 24 months, we did 23 meetups. So please spread it. That there, it's our goal to spread the knowledge and our experience in the .NET with more people, and for that we need your help. Yeah, again, our where you can find us, all our resources, quick in the chat to everybody. And the last thing is, yeah, we want to make this better, our meetups, and also with now the new streaming infrastructure. And to make things better, we need feedback from you all. And if you could fill out quickly the feedback form, that would help us immensely. And also this gives you the way to enter the raffle for the Hey Friends t-shirt. Yeah, sadly only for Austrian viewers. Yeah. And with that, yeah, we are at the end. Again, Will, thank you for joining us today. And to all of you, have a nice rest of evening, good night, good morning, and perhaps you still enjoy now the .NET the other talk spots there. I hope we see us in the next one. Bye.
Bye, everyone. Thank you.